we have already seen the priority scheduling. For this we have seen the example and we have solved this example using non-preemptive method in the previous session. In this session we are going to see the same problem under preemptive methodology. Okay, the concept of preemptive is that while a lower priority process is occupying the CPU and an higher priority process newly arrives in the queue, the lower priority process will be preempted and it will be placed on the waiting queue, and the higher priority process will be allocated for the CPU. Okay, in this problem we are having the process P1, P2, P3 and P4 respectively. Its burst time and arrival time and the priority are given. Okay, at the time of 0 milliseconds the process P1 arrives and it occupies the CPU. From 0 to 1 millisecond the process P1 will be executed, and at the time of 1 millisecond the process P2 arrives on the queue. While comparing the priority, process P1 has the value of 3 and P2 has the value of 1. The lowest value has the higher priority, as I said before. So the process P2 has the higher priority than P1. So P1 will be terminated. It will be preempted and it will be placed on the queue, and P2 will be allocated for the execution. So P2 starts its execution at the time of 1 millisecond. It will be executing till 2. At the time of 2, another process P3 will be arriving. So the priority of the 3 process which was in the queue will be calculated. For P1 it's 3 and P2 it's 1 and P3 it's 4. So comparatively P2 has the highest priority. So it will continue its execution from 2 to 3 millisecond. At the time of 3 millisecond the process P4 arrives in the queue. In this, the process P4 has the priority value of 2, and while comparing all those priority, now also process P1 has the higher priority, P2 has the higher priority, so P2 will continue its execution. So till the completion of process P2, it will be occupying the CPU. From 1 millisecond plus its burst time 4 equal to 5 is the completion time of process P2. Okay, whatever at the time of arrival of each process, the priority will be checked and the execution will be continued on the CPU. This is the concept of preemptive priority methodology. Okay, then after completion of process P2, next P1, P3 and P4 are in waiting queue, right? Comparatively P4 has the highest priority of 2. So P4 will be allocated. P4 starts at the time of 5 millisecond and its burst time is 5. 5 plus 5 equal to 10 is the completion time of process P4. And then finally P2 and P4 has completed its execution. Now P1 and P3 are in waiting queue. P1 has the highest priority than P3. The priority of P1 is 3, so it will be allocated for the execution. In this, the process P1 has already completed its execution of 1 millisecond in the CPU. So its total burst time 8 minus 1 equal to 7 is the current pending time. So it will consume the CPU for 7 milliseconds. Its starting time is 10. 10 plus 7 equal to 17 is the completion time of process P1. After that, finally process P3 is in the queue. So P3 will be allocated. P3 starts at this time second of 17 millisecond. Its burst time is 9. 17 plus 9 equal to 26, the completion time of process P3. Then using this Gantt chart we will be finding the turnaround time and waiting time. The formula used for calculating turnaround time is turnaround time equal to completion time minus arrival time, and waiting time equal to turnaround time minus burst time, right? So In this problem, turnaround time for process P1 equal to its total completion time is 17 minus its waiting, its arrival time 0 equal to 17 is the turnaround time of process P1. For P2, its completion time is 5 minus its arrival time 1 equal to 4 is the turnaround time of process P2. For process P3, its completion time is 26 minus arrival 2 equal to 24 milliseconds is the turnaround for P3. Then for process P4, its completion time is 10 minus its arrival time 3 equal to 7 is the turnaround time of process P4. For finding the average turnaround time, we will be finding the average of P1 to P4. 17 plus 4 plus 24 plus 7 equal to 52 divided by 4 equal to 13 milliseconds is the average turnaround time of the process under preemptive priority scheduling. And for finding the waiting time, the formula we are using is turnaround time minus burst time. For process P1, its turnaround time is 17 minus its burst time 8 equal to 9 is the waiting time of process P1. For process P2, its turnaround time is 4 minus its burst time 4 equal to 0 millisecond is the waiting time of process P2. Then for process P3, its turnaround time is 24 minus its burst time 9 equal to 15 is the waiting time of process P3. Then for process P4, its turnaround time is 7 minus its burst time 5 equal to 2 is the waiting time of process P4. For finding the average waiting time, we will be finding the average of P1 to P4. 9 plus 0 plus 15 plus 2 equal to 26 divided by 4 equal to 6.5 is the average waiting time for this process under preemptive priority scheduling. Okay, we have seen the same problem under preemptive and non-preemptive methodology. As it in SJF, the preemptive SJF will be having the minimal waiting time, right? So comparing to the preemptive and non-preemptive methodology, the preemptive priority will be having the minimal average waiting time. For the same process, when we see in non-preemptive methodology, the turnaround time is 14.25 and waiting time is 7.75. While solving the same under preemptive priority, its turnaround time and waiting time is 13 and 6.5. It is gradually decreasing. So the preemptive priority will be having the lowest waiting time compared to non-preemptive methodology. So I think it will be clear for solving the problem under priority scheduling using preemptive and non-preemptive methodology in today's session. Thank you.